angle pairs. So we're going to look at how angles in a diagram, in a figure, are related to each other in a pair, so how two different angles are related to each other, and how we can use that information to figure out measures that we don't already know, that aren't specifically told to us explicitly. So first we're going to talk about some pairs of angles, some you already understand and some you've already heard about and learned about, and some that may be new to you. So first we're just going to start with a basic piece of looking at geometry, a transversal. A transversal is a line that intersects two or more lines. So if we look at this picture that we have here, I have these two lines, and here is a transversal. Transversal cuts between two or more lines. I also want to talk about these two lines. These two horizontal lines are parallel to each other, and I know they're parallel to each other because of this little filled in triangle on each of the lines. Since they both have one triangle on them, they are parallel to each other. Similar to how when we looked at polygons, and we might do one little hash mark on two different lines to show that they are equal to each other. Here, this little notation means that these two lines are parallel. So back to my transversal. A transversal is just a line that cuts through two or more other lines. Let's talk about some angle pairs. Supplementary angles, two angles whose sum is 180 degrees. So if I look at two angles that are part of a straight line, these two add up to 180 degrees. Complementary angles, two angles whose sum is 90 degrees. So if I have a right angle in here, I know that, and it's made up of two angles, those two angles have a sum altogether of 90 degrees. All right, angle pairs, vertical angles. You may not have heard of this one. Vertical angles, opposite angles formed by intersecting lines. Vertical angles are congruent to each other. So if I look at this diagram over here, I have two lines that are intersecting each other, and across from each other I have vertical angles. And when I have vertical angles that are opposite from each other in two intersecting lines, these are congruent, they are equal to each other. So sometimes that's important to us. And our last one, corresponding angles. When a transversal intersects parallel lines, corresponding angles are congruent. So if we think back to our polygons, our congruent polygons, we talked about corresponding angles and corresponding sides, which simply meant that if I took one of the figures and put it right on top of the other figure, they would match up with each other. They correspond to each other. Same thing here. So if I took kind of this intersection that I have here of these two lines and was able to cut it right out of there and put it on a transparency like we've done in class, I could put it right over on top of my other intersection here, and all of these would match up. So you'll see that these two angles in the upper right-hand corner are congruent to each other. These two angles in the upper left are congruent to each other. These two in the bottom left are congruent to each other, and these two in the bottom right are congruent to each other. So we're going to use these facts to go from one small piece of information and really expand it to learn a lot about multiple angles. So let's look at some lines and how they intersect and what we create. So for this first one, we're going to use the figure to find the measures of each angle, and we're going to explain. So I want to be able to give a reason what type of angle pairs allows me to know that particular piece of information. So they want us to find angle 1. So here we have our two parallel lines. I know they're parallel because of these little filled in arrows that are on top of them. I have a transversal that's labeled T. It's a transversal because it's cutting across two or more lines. They don't have to be parallel, but in this case they are. One of these angles is given to us, so they've given us a 99-degree measure on this angle over here on the left, and they want us to find the measures of angle 1 and angle 2. So angle 2 is down here. So again, if I imagined that I could cut out this intersection of these two lines, pick it up, and I could put it right on top of this other one, I would notice that the 99-degree measure corresponds to angle 1 here. So I could label that 99 degrees. And I tend to, when I'm working with angles like this, label things as I go. So I know the 99 and the 1 are congruent to each other because they are corresponding angles. So I'm going to say this is 99 degrees because it corresponds to the 99-degree angle measure that I already have. Well, what about angle 2? Well, angle 2 doesn't correspond to 99 at all. However, I know that angle 1 and angle 2 are supplementary because they form a 180-degree angle along that straight line. So I'm going to do 180 minus 99. That gives me 81. So I know that this angle is 81 degrees, and it's 81 degrees because it's supplementary to angle 1. So when it says explain, this is all I have to do for my explanations. All right, let's look at one that has a few more angles to it. Use the figure to find the measures of the numbered angles and explain. So again, explain the same way we have here. Again, as I do this, I'm going to label each of my angles so I remember which one's which. I don't have to keep referring back to my list that I have going here. All right, so angle, we know this one is angle 60. This is a 68 degree angle measure in the middle here. Angle 1, so angle 1 is vertical to the 68 degree angle. And we know that vertical angles are congruent. So angle 1 here is 68 degrees. And I know it's 68 degrees because it's a vertical angle to the 68 degree measure that's been given. All right, angle 2. Angle 2 is supplementary to my angle 1. So I know 180 minus 68 is 112. So I know angle 2 is 112 degrees because it's supplementary to angle 1. It's also supplementary to the 68 degree angle, so I could have explained it that way. Angle 3 over here, I can talk about it a few different ways. It is vertical to the 112 angle. So I know it is 112 degrees because it's vertical to angle 2, not angle 1. It's vertical to angle 2. I could have said that it's supplementary to angle 1. That would have worked. I could have said it's supplementary to 68 degrees. All of those would have worked as explanations for why angle 3 is 112 degrees. All right, let's go over here to this intersection over to the right. Notice it's not connected to any of them, but because these two lines are parallel, and I know they're parallel because of that little triangle there, because they are parallel, I know that these two intersections correspond to each other. I could pick this one up and place it right on top of this other intersection, and my angles would correspond to each other. So I'm going to start with, we'll start with angle 4. I like to list them all out to start to make sure I don't miss any. So I'm going to start with angle 4, and angle 4 corresponds to angle 1, which is 68 degrees. So I know angle 4 is 68 degrees. So 68 degrees corresponds to angle 1 because angle 4 corresponds to angle 1. Now all the rest of these, because they correspond to all 4 angles in my first intersection, I could absolutely just say corresponding. So I know that angle 5 corresponds to angle 2, so that is also 112. But at this point I could get a little more creative. I could say angle 5 is 112 because it's supplementary to angle 4. That would absolutely work. Angle 6. Now angle 6 is corresponding to the 68 degree angle here. So I know that's 68 degrees because these are both in the upper right hand corner of my intersection. But I could also say it's the vertical angle from angle 4. I could have said that it's supplementary to angle 5. That would work also. Angle 7. Angle 7 corresponds to angle 3. So I know that is 112 degrees over here. But again, I could have said it's vertical to angle 5. I could have said that it's supplementary to angle 4. I could have said that it's supplementary to angle 6. So when we get to those last few, there are a few different ways we could explain why we know that that angle measure is what it is. We just need to list one of them, and this is what our list is going to look like. So again, we're using angle pairs, what we know about angle pairs that are congruent to each other or related to each other, as in supplementary angles, to figure out the measures of angles that haven't explicitly been told to us.